manual process I'm just want to discuss with you, so that we will share you these PDFs also and PPTs to you, so that you can refer the manual procedure of design of any footing, so that the concepts will be clear in this. Okay. And then we will see how to design the footing by Excel programs also. So we are having some Excel programs and Excel spreadsheets by which we can quickly design any footing. So that is also there. Okay. So before, let's start with the manual design of footing concepts. Okay. So let's say this is our problem statement. Let's say we are having grade of concrete as M20, grade of steel as 500. Generally cover to the reinforcement in footing is between 50 to 75. So let's take 50 clear cover. Then column dimensions 300 by 600, and SBC soil bearing capacity 300 kilonewton per square meter, and axial load on the column is 1500 kilonewton. Okay, so before that, let's see some concepts. So I think many concepts are clear to all of you, but still again, let's go ahead. So let's say we have one column and the column is resting on a footing. All of you know that. So can anybody tell me why the footings are provided? What is the purpose of footing? Yes.
So to transfer the load from superstructure to the hard strata.
Yes. So from this column to this, there is a hard strata here, over here, hard morum or rock, whatever there is. It is always below the ground. Footing is generally below the ground only. So whatever this load has to be transferred to this hard strata, and that too uniformly, we can say. So uniform distribution should be there. So the load will transfer like this, we can say. Uniformly, uniform distribution will be there. And for that uniform distribution, we are having area of footing actually. So we provide sufficient area so that the load will transfer. We cannot directly put the column on the hard strata directly. Okay. It may punch into the hard strata or there may be any consequences. So generally this is the procedure. So we provide one footing there to transfer the load. And as this column is resting on this footing, there will be stresses at this point. So whenever we design any column, in column design, we take care of these stresses over here. So there are stresses here at this junction, and we take care in the column design. And due to this column load, it transfers to the footing, and there is a self-weight of the footing. So column load plus self-weight. So there will be stresses here at this point, right? So there will be stresses at this junction level. The stresses coming on the soil or strata. So whatever soil, so all of you know that any soil is having a capacity. So capacity of soil, we generally call it as a soil bearing capacity, SBC. So whatever stresses are coming on this soil from the footing level, we can say from footing, the capacity should be more than the stresses, or generally we use this word for these stresses, actual stresses, we can say actual stress. We use the word as a bearing pressure. So whatever bearing pressure is coming from the superstructure or from the column and footing, it should be less than the soil bearing capacity. That means SBC should be more. So what we need to do, we need to calculate the actual stresses. Okay, first. So due to this, what will happen? Due to this above load, what will happen? The upward, see,
Punching
there is,
shear.
so this downward load is there. So this is action, we can say. This is action, downward load. Whatever download load is a action, and due to that, there will be reaction offered by the soil. So the soil will offer reaction to that, and this we call it as upward pressure. then and then there will be equilibrium, downward force and upward reaction. That is a equilibrium condition. So we can say that it is upward pressure. Upward pressure due to soil. Now all of you know, so this is your equilibrium condition. Now you can analyze the structure. So first of all, the structure should be in equilibrium, and then we can analyze. So there is a pressure and there is a, so if you look at this column and footing arrangement, so this column acts as a support, we can say. So let me draw this as a support. And there is a footing which is having a cantilever. And there is a pressure, upward pressure. So whatever, let's say this is a length of footing, L. So this will be half is L by 2. See, I'm just conceptually saying an L by 2. So all of you know that as it is a cantilever, but with upward pressure. What will happen due to this cantilever and due to this load?
Great. Bending moment is done.
Yes. Yes. So bending moment.
Moment
All
is
of you
done.
know that there is a moment will be there and moment will be at the support. It will be. So let me show this in different way. Let's say this is your support and these are the cantilevers, and this is your downward load. Generally, we are used to see such kind of pictures, downward force. So as this is a balanced cantilever, it will offer a cantilever bending moment like this. So in this case, it will be at the bottom. So 0 at the free end and then here at maximum and again here. So this will be the M max, right? So because why this bending moment is getting generated? Because it will deflect actually. So due to the deflection. So how will it deflect? It will deflect something like this. This will deflect due to the upward pressure. It will deflect like this. So where is the tension in this case? Tension at the bottom and compression at the top. As it is a upward cantilever, upward pressure. Is it clear? As the tension is at the bottom, then we will provide steel at the bottom. So how we will provide the steel at the bottom? So we will provide the steel at the bottom because there is a tension at the bottom. Now this is not a beam, actually it is a footing. That means it has an area, right? So if you look at the plan of the footing, so it is something like this. And there is a column, let's say there is one column over here. So due to the upward pressure, so there is a bending in both directions, as it is kind of slab, we can say footing is a kind of slab. So all of you know that there is a two-way bending. It is not only one way. This is from one side. So let's say we have considered this as a L. So there will be bending in this along L. So we can say that there is a cantilever moment. So it will deflect like this. So I'll show you the bending moment actually. So if this is the case, then the bending moment will be like this. So I'm showing the bending moment in plan actually, but it is in section. Please try to understand. So this will bend in this direction due to this kind of. And again, there is a bending. So bending is here in this direction. So the bending is like this also. And there is a bending like this also in this direction also. Two-way bending. So there will be bending moment here in this direction also. So two-way moment. Let's say this is your X, if this is X, and let's say this is your My, whatever you name. So two-way bending. So this bending I am talking about. Okay. So this is Mx here and My here. Okay, fine. So this is the two-way bending. And it is a cantilever behavior. What other forces will be there apart from bending moments? So there is a bending moment. So all of you know that whenever there is a bending moment, whenever there is any bending in any member, what is there? Additional
Stresses are
force.
there. Stresses are there.
So we have a shear force actually, shear force, right? So there will be shear force in the footing. So shear means all of you know that the shear is generally we see shear cracks like this, diagonal cracks, isn't it? So these are the shear cracks developed due to the bending. Correct. So it may crack like this. And generally this crack happens at a distance d. Okay. So d, small d, whenever I say small d, what is small d? If it is a capital D, that is total depth. A small
Effective
d,
depth.
say it's a effective depth actually. D means effective depth. D minus cover minus diameter of the bar by 2. Okay. So shear will happen at this. So this shear we call it as a one-way shear actually. One-way shear. So there is a shear. Okay. And one thing pending that see, as I said, this will be the bending moment, and we will design this steel for moment mx in this case, because this is the mx moment in this direction, x direction. So there is a moment in this direction also, that is my. So because this will bend like this also, so we will provide steel here also in the form of this along that direction also, dots. Correct. So generally there is a mesh for reinforcement. So this mx will be taken care by this steel reinforcement, horizontal steel. We will design this horizontal steel for mx moment, and we will design this steel for my moment. Okay, so this green is nothing but that dots which I have shown. So this is the general behavior of the, right. So this is a green, we can say this green we will design for that my. What else will be there? So there is a bending moment due to the loads. There is a shear force due to loads. And this shear force, I am saying one-way shear. Is there anything which may is possible?
Two-way shear.
Yes, two-way shear. Two-way shear means we can say it is a punching shear. So as the column dimension is generally less compared with the footing, and footing is having a less thickness in general, I'm saying. And then there is a possibility that this will punch, correct? Because this area is very less. So as this column area is very less, so there will be heavy stress actually. Heavy stress. And due to that, there is a possibility that it will punch. Okay. So this whole portion may punch like this. So there will be shear in this direction like this. Okay. So the whole block will try to slide down. So if I show you, I will show it. Let's say this column is there and I'm just putting this force on the column. So this will try to go inside the footing. So it may slide. I'll just show you. How will it shear off? So it will be something, this will be a crack like this. And I can say that it is something like this. So it is going down. So you can see in this zone, there is a shear. And if you look it in the plan actually, so it is not only in this direction. So there will be shear so shear, if you see the crack, shear crack, so it will be something here nearby this on all the four sides. Okay. So whatever this portion I'm showing, this is like this. And generally this shear happens at a distance d by 2. Okay. D by 2 from both the sides. So this zone. Now who is causing this shear actually? So the pressure which is here. Can you see this pressure? Offered due to the soil. So this pressure is trying to push it. So it is trying to go down and this pressure is trying to move it up. And due to that, there is a shear. So the shear stress. So this shear, we call it as a two-way shear. Or we can call it as a one punching shear. The same punching shear as it is trying to punch. And this punching shear or two-way shear is caused due to this pressure, PU, let's say upward pressure, all round. So whatever this area is available here, surrounding to this, around this crack, we can say. So that pressure, this total pressure into this area, whatever green hatch I have shown, that is nothing but the shear force, punching shear force, we can say, which is causing this punching shear. So this total area, green area, into this PU. So there is an area, punching area, let's say AP. AP into PU is nothing but the shear force, punching shear force, we can say. So this is the concept of two-way shear. So these are the three things. So this is one-way shear, and then there is a two-way shear. Two-way shear. In one-way shear also, whatever this portion is there, so there is upward pressure here after this crack. So this pressure will cause the one-way shear. Okay. So all of you got this overall concept of the footing, behavior of the
Yes,
footing.
sir.
Now let's go to the problem statement. So that means we need SBC, soil bearing capacity for any problem, then column dimensions, actual load on the columns, okay, and grade of concrete cover and everything. So now apart from the load on the column, there is a self-weight of the footing. Okay, so self-weight you can calculate either by assuming some footing size, or as a matter of simplicity, you can assume 10% of the column load. So for self-weight of footing, because we have not yet designed. Okay. See, this session is only to understand the manual procedure and what are the steps involved. Once you understand the steps of the manual calculation, then we are using the Excel programs directly. So it will calculate automatically the self-weight and all these things. So don't worry about that, but try to solve this problem. Now let's assume self-weight of the footing as a 10% of the column load. So 10% is 150 kilonewton for this. So total load at the base of the footing will be 1650 kilonewton. Okay. Now, if you want to calculate the area of footing, how can you calculate? So you know the capacity, SBC. So load divided by SBC. Okay.
Yes, sir.
Now try
Yes.
to understand the key point over here is, this is working load. Please try to understand working load, not ultimate load. Because whenever you calculate the size of the footing, that is area of footing, we take this load as a working load. Okay. So this is important. So working load divided by SBC, that is the area of footing required. So this divided by 300 is 5.5 meters square. That is the area required. Now you can assume any length and any width such that your footing, for example, let's say it is a 5.5. So you can assume when there is a rectangular column, I don't know whether it is it rectangular, 600 kuch to hai na? So the column's size is 300 by 600. That means it is a rectangular shape. So you can provide rectangular footing. Okay.
सर यहाँ फैक्टर ऑफ सेफ्टी नहीं लेते
कौन सा किसका?
लोड में पीयू नहीं लेते क्या सर
PU is used for design, मतलब steel design and shear force design उसके लिए. For sizing it is not taken because this is also SBC we have calculated for working condition. Okay. So there will be double size otherwise, right? So it is net SBC is working. Okay. And here already factor of safety is considered in soil bearing capacity. Okay. That's why we
ठीक है
don't take here also. Okay.
ठीक है
Yeah.
Okay.
So SBC में already लिया है इसलिए यहाँ नहीं लेने का. Now, as we have the size of the column as a rectangular column, let's say 300 by 600. है ना? So we can provide rectangular column, rectangular footing. So why we provide rectangular footing? So generally there is no compulsion actually. So we try to keep this distance as same as this distance, equal projections. Okay. So if it is a 1 meter, then we will try to keep this also as a 1 meter. Okay. So the reason is, what is the reason of keeping the projection same? Anybody from you? क्यों रहेगा ये? Equally रखना है हमें डिजाइन करते समय. Possibly, not necessary.
So uniformly
Uniformly,
distribute that load.
So actually uniformly distribution के लिए कुछ problem नहीं है, but the benefit of this is, see, we have a two-way bending. ऐसे भी bend होने वाला है ना. We have already drawn that shear force moment diagram.
Yes.
So ये moment ऐसे होने वाला है, and in this direction also there is a moment. So whenever we calculate any moment, m is nothing but WL square by 2.
Yes, sir.
So ये W और ये जो हमारा 1 ही रहेगा 1. तो दोनों साइड का बेंडिंग मोमेंट निकालने की जरूरत नहीं. There is no need to calculate the bending moment on both the sides, because I know the projection is same on both the sides. So in one step we can design that, but it is not compulsory. There is no compulsion on that. So if you have different projection also, you design both way, then bending moment in X direction, bending moment in Y direction, and then design the steel different in each direction. So there is no problem. You can do that way. But if you keep it, it will be easy. Generally, we used to do it for manual calculation to avoid the, say, calculations. Now we have a spreadsheet, so you can have different sizes. Now, so how to keep that projections equal? The procedure is given over here. You just study that. You can make it. There is no problem. I'll not go in that detail because you just go through that. Now we have got the footing size as, by using that method, as 2.3 by 2.6. So what is the area of footing provided? 2.3 into 2.6 is 5.98, and which is more than required. कितना था हमारा?
5.2.
Required 5.5. So it is 5.98. So more than. So okay. So now you can, this is your B is 2.3 we have chosen, and this has a 2.6, and the column size is 300 by 600. So we have given the size to the footing now according to the load. So load divided by SBC is the area of footing required, and then you can choose any length and any width as you wish. Okay, try to keep this projection nearly same. It little difference is okay, fine. Now next step is, so we know that due to the axial load on column, there will be upward pressure, correct? That upward pressure, how can we calculate? Load divided by area, P by A. So if this is a P, then this pressure is P by A. A is the area of footing, so AF, let's say. Now whenever you calculate this upward pressure, then you need to calculate the ultimate pressure. So multiply this with 1.5. So 1.5 into P upon AF is nothing but upward pressure, PU or PAU, whatever you name. So this is the upward pressure, PAU. Okay. So here you can see factored load on the column. 1.5 into axial load upon area provided, area of footing provided. So this is your upward pressure, 376.25. 376. Now we have got the upward pressure, so it will bend actually, and due to the bending, there is a bending moment. So what, how to calculate the bending moment? Bending moment कैसे निकालेंगे? This is your projection. So this projection we are writing as a CX from the face of the column. So you can see here the bend, it will bend at the face of the column. So this is your CX from the face of the column till the end, and this is your CY. Okay, are you getting this?
Yes, sir.
So there is a CX, there is a CY. So here we are calculating this CX. So you can, by observation, you can see you need to subtract this length from the column and divide by 2. So 2600 minus 600. 2.6 minus 600, that is 0.6, divided by is the nothing but your CX. And this CX is required for calculation of bending moment. So this is your W, this is PU into L square by 2. L is nothing but this CX, cantilever projection. So you got this MUX is 188.125. And similarly on the other side also you need to calculate, that is CY. So on the other side it will be CY. So you calculate that also. So CY is also same 1 meter. So we have kept that projection same actually in our case. So this will be PU into this into CY square by 2. So this one. So you got the bending moment in both the direction, MUX and MUY. MUX is 188. MUY is also 188 because we have kept this CX and CY same. So once you get the bending moment, ultimate bending moment, so what you get, what is required then? So what our aim is to calculate the AST, that is steel. So steel is based on the bending moment. In conceptual, it is nothing but bending moment divided by permissible stress, that is 0.87 Fy. Yes, then
JD.
J into D. Okay. So J is lever arm. So all of you know this basic concept what we have learned. But in
Yes, sir.
RCC, we are using different formula here. So we will see that. So before any
0.5
section,
Fs.
yes. So whenever we design any section, either beam, slab or footing, whatever, there is a capacity to the section actually. So any section has a capacity. Let's say we consider as a beam, and this is your B and this is your D. So the maximum moment this section can carry can be shown like this actually. So how much maximum moment it can carry, so that it will be balanced section and under reinforced section. So this is the formula, 0.133 FCK BD square. So this is nothing but MU limiting, maximum moment you can carry as a singly reinforced beam and balanced section. Okay, this is nothing but R into B into D square. So R
Yes,
is
sir.
in our case 0.133 into B FCK. FCK. Okay. So this R is nothing but 0.133 FCK. Here, not here. FCK. So this is your R into B into D square. So you can equate this with your moment, whatever you got, 188 point. So here you can see that equation. So 188 and 0.133 FCK BD square. We are interested in D. So what is the D required for this moment calculation? So D required is 265.94. D is the effective depth. So you need to add the cover and D by 2 in that case. Okay. So if you assume 12 mm diameter, then overall depth will be 265.94 plus cover 50 plus diameter by 2. So it is 321.9. So you can see, and now we have taken this 600 a little higher because if you consider, see, either you can take this as a, ये कितना ले सकते हैं, 350 भी ले सकते हैं ना, required is
400 सर,
या 400 भी ले सकते हैं, बट क्या होगा बाद में shear में फेल हो रहा होगा, इसलिए हमने किया है वो. So there is a reason that it might have been failed. If you consider 400, it may be failing in shear, and again you need to revise the section. So that's why I think we have taken on the rounding on the higher side. But because see, manually, if you do it iteratively, first of all you will assume 350, then it fails in shear. Let's say assuming 400, again fails. Then again you will assume 500, again fails, and then at 600 it is pass. So you are doing 1, 2, 3 times design, and then you are getting at this number. So it is really, we can say, difficult process and time consuming process, we can say.
इस केस में हम लोग जितना डेप्थ आ रहा है उसका दुगना लेते हैं.
No. See, this is not. It should be just near to required. Now, we don't design manually always continuously. Huh? We are only using the manual calculation for rough and approximate checking. See, we are using these Excel programs.
Okay,
Here
sir.
it will do it automatically. Exactly. I'll show you how to do.
Okay,
Don't
sir.
assume anything double or something. Huh?
Okay.
Just try to understand the steps here. We don't over design, please. So it should be safe also, and it should be economical also. So it is not that take double or 1.5 times. It should be just matching the safety. Okay.
Okay, sir.
Yeah, I think नहीं कुछ तो गलत हुआ है यहाँ. It should be
कुछ ज्यादा ही सर अमाउंट.
ये 450 है. यहाँ 450 है.
450 होगा सर.
यहाँ कुछ तो गलत है फिर, I think.
नहीं सर, एक सर बताए तो वहाँ 450 होगा.
450 है 450.
हाँ 450.
600 ही बोला था सर, यहाँ पे जो ओवरऑल डेप्थ है ना, सर ने बोला था वो
नहीं नहीं, लेट मी
600 ही
चेक.
आएगी.
एक मिनट यहाँ देखता हूँ मैं. एक मिनट, यहाँ कुछ तो ये है. लेट मी चेक इन द 600 ही. इट इज 600.
यस सर.
600 ही है, 450
Okay,
नहीं.
sir.
कुछ तो गलत है यहाँ. I don't think so. There is a wrong something here. So forget it. Assume it. Just understand the steps. Forget this. Now let's say we are assuming 600. Now D effective is 600 minus cover minus D by 2. So 544 is the D effective. Okay, small d. Whenever I say small d, it is D effective only. Now how to calculate the AST? So there is a two AST in both direction. AST x, where this mu will be MUX. So 0.5 FC cap on Fy, this 1 minus square root. This is the formula for that.
Yes, sir. As per IS code.
Yeah, so as per IS code, then put this FCK 20, Fy, this, moment this into 10 raised to 6. B, so generally whenever we design any footing, we design as a slab, and where we take B as a 1 meter, please. So this B is 1 meter, 1 meter. So we
Yes.
design the steel for 1 meter and we provide the spacing throughout the length of the footing, length and width. Okay. And this is D. So ASTX required is 826. Now, if you assume 12 mm diameter, then how to calculate the spacing? I think all of you know this. Spacing is nothing but area of single bar divided by area, total area required into 1000. So this is your spacing, which is coming out to be 136. So you can reduce the spacing. Whenever you reduce the spacing, the steel is more. Okay. Don't round on the higher side, round on the lower side. Correct? So generally, whenever we provide any spacing in slab and footing, it should be in multiple of 25 mm generally, or 1 inch. So we can say 100 mm, 125 mm, 150, 175, 200. So the spacing should be like this. So even though it is 136, I am not providing as a 130 mm. I am providing 125. Just in it is easy for construction, laying the reinforcement for fitter, and there are many benefits of that. Okay.
Okay, sir.
So our steel is in footing is 12 mm diameter at 125 center to center. So this is in X direction, along X. Then there is other direction ASTY along Y direction. Same. Put here MUY. All other parameters are same. Then assume diameter and 12 mm at 100 center. Actually here 100 just for the simplicity we have taken. So there is no reason to keep as 100. You can consider 125 also. Okay.
Minimum 100 mm spacing column.
Minimum 100 I generally recommend, yes, in footing, because there otherwise there will be congestion of the concrete steel, and then concreting will not be proper. Compaction, vibration. We cannot use the vibrator properly. So there are many reasons. Don't go more than 100, less than 100 in spacing, either in slab or footing also, both. Okay.
Yes, sir.
So we have designed the steel. Now we want to design the footing for shear, one-way shear. So I have already told you one-way shear, where it is a one-way. At a distance, the cracked location is here.
D
at
distance.
a distance D from the face of the column. Here also D. So this is your critical section for one-way shear. This one. Okay. Now what is the shear force causing this one-way shear? How to calculate? So this total area into upward pressure. This area into upward pressure will be the shear force. Shear force is nothing but pressure into area. So how much is distance coming? If you take this as a D, then this will be 456 mm. If you take this as a D, it will be 456 mm. Okay.
Okay, sir.
This is required to calculate the pressure force. So you can see here, offset is calculated X. This CX minus D. So itna 0.456 aa raha hai. Then shear force along X direction is nothing but this X into L. X into L means वही area है ना, मैं जो बताया मैंने.
Yes.
So this X into this total L. L in this our case ये आ रहा है ना. Yeah. So see, we are not taking, see, as we are designing the footing for calculation of AST, we have used 1 meter width, right? So in the similar fashion, you can consider this as a 1 meter. So यहाँ से यहाँ तक लेना है हमें. So my area will be this, and this is nothing but my 1 meter. Okay. So calculate the shear force for 1 meter, and we will design for 1 meter only. So we are generally designing the slabs and footings for 1 meter width. Okay. So what will be the shear force? This X into this 1 meter into upward pressure. So this X into L, that is 1 meter, into upward pressure is 376. Upward pressure we have already calculated. PAU 376 tha na. I'll show it again. This one upward 1.5 into load on the column divided by area. Okay. So we can calculate the shear, this one. PAU. So the shear force is VUX in X direction 171, and in Y direction you have to take this as a Y into B into PU. In our case, actually it is same, because this is same, this is same. So shear force will be same. VUX is also 171. VUY is also 171. If you have this X values and Y values different, then this will be also different. Huh? Keep in mind. And
Yes,
even
sir.
moment will be different. ASTX का जो moment था ना, MUX
Yes,
and
sir.
MUY वो भी अलग आएंगे उस केस में. So we got the shear force. So once you get the shear force, you need to calculate the shear stress, actual shear stress, that is VU upon BD. So VU upon B is 1 meter. We have already taken here 1 meter. D is small d. So 0.32 is the shear stress. Now we have calculated the actual shear stress coming on the footing due to the load. Now we will calculate the permissible shear stress as per the code. So in code, we have the permissible shear stresses given in table 19, IS 456. Okay. So permissible shear stress depends on the percentage steel provided. So what is the percentage steel we have provided in the footing? 100 into AST
0.21%, sir.
upon BD. So 100 AST provided हमारा 1 कितना था? तो उतना ही आ रहा होगा 1130. 12 mm at 125 है ना हमारा. AST provided कितना आएगा? Let me check it out. So AST provided is 12 mm है ना हमारा ये 12 mm at 125. Let's check it out. So AST provided कैसे निकालना है? हमारा फॉर्मूला क्या है स्पेसिंग का? AST अपॉन कैपिटल AST मतलब into 1000. So we will multiply spacing into, ये AST है ना तो ये नीचे आएगा. So small AST upon spacing into 1000. So small AST 12 mm का कितना है? सिंगल बार का एरिया 113, then spacing is 125 into 1000. कितना आ रहा है ये? AST provided. Is it correct? Not sure.
I think capital AST should be at the top and small AST should be at the down.
ऐसे हो रहा है? Actually, this is not for 125, it is 100. So we have taken 100, I think. Okay.
Yes, sir.
So if you take this as 100, then it will be 113. So this will be 1130. Okay. So we have considered that 100. Okay.
Yes.
In this case, we need to correct that, I think so, for avoiding confusion. But try to understand the concepts. So this is provided steel, which is nothing but 12 at 100. So 100 AST upon BD. So this is 0.21%. So in this code, all of you might have seen this 456 देखा है ना आपने?
Yes, sir.
So in this code, you'll see that in 456, so yeah, here in this table 19, you can see here, our grade of concrete is 20 and 100 AST upon BD is nothing but percentage steel. How much it is coming in our case? 0.21 है ना कुछ तो? 0.21%. So as it is 0.21, so you can see here, it will be something in between 0.15 and 0.25. इसके बीच में है that PT. So that means our permissible stress will be in between 0.28 and 0.36, right? Getting?
Yes, sir.
So this is your permissible shear stress tau C. So you need to interpolate that. Okay, in between this 0.15 to 0.25 yahan point. So this is a question mark. So you can interpolate and you get this value as something 0.32 RM C. Okay. So just matching. So we can say it is a safe, just matching. So tau C greater than or just equal to tau V, safe in one way shear. So you got this process.
Yes, sir.
So calculate the shear force by using this X into L into PU upward pressure. Then shear force divided by BD is nothing but tau V, that is calculated shear stress or nominal shear stress, 0.32. Then calculate PT, that is AST provided. So 100 AST upon BD, that is 0.21%. So according to 0.21, interpolate this in between this between 0.28 and 0.66, just 0.32. So safe in one way shear. Now there is a second shear stress, that is two-way shear stress. So we have already seen two-way shear stress is at a distance d by 2 here. From here d by 2 and again here d by 2 all round. So this is nothing but the punching shear area. So who is causing the punching shear stress? I have already told you here. So this green hatch area is causing the shear stress, punching shear. So this green hatch into upward pressure. So green hatch area. So in this case, it will be this area. That means if you want to calculate this hatch area, then you need to calculate the total area 2.6 into 2.3 minus this dotted line area. Correct?
Yes, sir.
0.844. Then you will get this hatch area. So let's say how to calculate the punching shear stress. So here you can say shear force on shaded area is given by footing area minus critical shear area, right? Into upward soil pressure. So this is your shear force. Getting this area minus this area into upward pressure. This is a shear force. Now how to calculate the shear stress? Shear force divided by BD, VU upon BD. So VU is this, B is, now in this case, we are considering this B. So this is B, which is this B? Now the B is here in this case, B calculation is nothing but the perimeter of this dotted line. Okay. Getting? So V upon B into D. ये perimeter समझ में आ रहा है क्या कुछ? Anybody is getting this? This B is the perimeter of the critical section. Yeah, this perimeter. So shear stress we want to calculate, that means this total force, green hatch area force, is the stress is generated at the perimeter of this section. You can see if you look at this image, because it is getting punched from all round. So there will be shear all round actually. That's why VU upon BD. B is nothing but that perimeter of the dotted line. So this you can see 2 into 1144 plus 844. This is the perimeter of this dotted line. So VU upon BD. So this is that. Now shear stress. So the formula for here is different. Permissible stress, shear stress I want to calculate, which is nothing but Ks into 0.25 root FCK. This is as per IS 456. And the case is minimum of 1 or 0.5 plus beta C, where beta C is width upon depth of the column. So width is 300 for column, depth is 600 for column, so it is 0.5. So 0.5 plus 0.5, 1. So therefore Ks is 1, minimum of 1. Therefore tau C will be 1.118 Newton per mm square, and actual shear stress is 0.87. So permissible is greater than actual, so safe in two-way shear. So we can provide this T12 at 100 center to center, and the depth of footing is 600, and size we have already arrived at. So this is the in general procedure for design of footing. All of you have got this concept?
Yes, sir.
Any questions in this?
सर वो प्रोजेक्शन के लिए थोड़ा सा इस पर थोड़ा दिक्कत है ये। हाँ,
कौन सा प्रोजेक्शन?
बोथ साइड जो इक्वेशन लिए थे सर।
टू वे शेयर, वन वे शेयर, या
नहीं सर, ऊपर में डायमेंशन जो निकाले थे हम लोग उससे।
हाँ, डायमेंशन। सी यू रीड इट ना, ये 0.6 ये कैसे निकलना है?
हाँ सर, ये 0.6 प्लस 2x ये कैसे आया वो?
See, generally, don't go in this. I will tell you कैसे बताना है। ये एक क्वाड्रेटिक इक्वेशन बनाया हमने।
हाँ, क्वाड्रेटिक।
डोंट गो इन दिस, मैं बताता हूँ। इसी ट्रायल एरर से करना है, मैं बताता हूँ कैसे करना है। सी बेटर वे टू डू द ट्रायल एरर, अदरवाइज यू नीड टू गो इन मैथ्स एंड ये क्वाड्रेटिक इक्वेशन बनाना पड़ेगा। ओके, ये बना सकते हैं, बट लेट्स गो अहेड। ओके, मैं बताता हूँ, क्योंकि सी ट्राई टू अंडरस्टैंड कि ये इक्वल चाहिए, ये प्रेशर ऐसे निकालते हैं, परमिसिबल स्ट्रेसेस वी गेट फ्रॉम द कोड लाइक दैट। So that you just try to understand this, because don't go in too much calculations. Understand?
Okay, sir.
I'll tell you कैसे बताता हूँ मैं, क्योंकि see there are a lot of things to go ahead actually. That's why I'm not going in smallest detail of maths and other things. So just go ahead, read that and come again. Now यहाँ तक समझ में आया सभी को procedure, overall understanding of the behavior of the footing.
Yes,
okay,
sir.
So this is the behavior of footing. This is the manual calculation procedure as per IS 456, how to design the footing for axial loads. Right. And this is the steel provided, we got this. Now we will see how to design the footing by using Excel programs. The only problem in this sheet is that it is designed for working stress only actually. So that limit state design method is under progress in our office actually. This sheet is for design of footings using working stress method. Okay, but the steel generally comes same, it becomes safe. It is not that working stress is giving unsafe design or limit state is giving safe design. No, whatever you get, it will be almost near to your limit state method. So let's use this sheet for footing design. So how can we use? So first of all, let's assume grade of concrete. So this is a sheet. I think you are using such kind of sheet first time, isn't it?
Yes, sir.
पहली बार ही कर रहे हैं मेरे ख्याल से आप.
Yes, sir.
So okay, so this is a sheet and there are inputs, and the inputs are only in white color. So keep in mind, you cannot edit anything in between. This colored area you cannot edit. The input is only this white portion. So here you can see, you have to assume the grade of concrete, whatever you want, 20, 25, whatever, 30. Let's assume 20 grade of concrete and steel grade as a 500 grade. Okay. So this is the assumption. Now you need to know, you get the soil bearing capacity from the geotechnical report. So let's assume this as a 300 here in this case. Now generally if there is earthquake load or wind load, you can increase the SBC by 25%. So what is the 25% of this? 375. You can increase the SBC by 25% in case of earthquake and wind load. So in our case, there is no earthquake and wind load, so don't worry about that. But you should know this case. And density of dry soil, generally we take 18. And density of wet soil, saturated soil, we take generally 20. Okay. Now here you can see here. Now look at this picture. So this is a footing. There is a axial load on the column P. Then there is a moment. So in footing, actually, in columns we get moments also. Now I'm not going in detail for moment for the first sheet. So let's design our footing for axial load only in the beginning. So you can see there is a load, axial load P. Then there is a moment Mx and My. So Mx, My, and there is a this you can see there is a pressure, upward pressure, whatever you know. So this is the length of footing, width of footing, and this is the H, that is the footing depth below the ground level is H. If there is any water table, then this H dash is the depth of water table. And there is actual horizontal force due to the earthquake or wind load. So for the time being, just to understand, I will show you what are the meaning of this each term. So let's assume the footing name as a F1. I'll give the name. Now here I don't know anything here in this case for the. So you only know axial load on the column, which is working load 1500. So this is the only I know. I don't know the size of the footing because I need to design it. Okay. So first of all, you need to assume here L something. So approximately, tell me what is the area required approximately? 1500 divided by SBC. Correct?
Yes, sir.
तो कितना आएगा वो? 5 meter square.
5 meters, sorry.
So here कितना ले सकते हैं आप? You can try. Now it is an Excel sheet, so you can try. So 3/2 करेंगे. 3/2 का कितना होगा? 6 meters.
6
right?
meter. Yes, sir.
Okay, let's assume this 6 meter. थोड़ा higher लेते हैं. बाद में करेंगे क्या करना है. Now T, small t is nothing but the depth of the footing. Okay. So this also you can assume. कुछ भी assume करो.
1
Let's
meter.
say नहीं. कम से start करो कभी भी.
Okay.
Don't assume higher. Higher will always come to 0.3 मतलब it is the depth of footing or thickness of footing. H is the column size है. So this is your H. So column size कितना है हमारा? 0.6. Now we want to put all the dimension in meter here. 0.6 ये मेरा footing depth है, sorry, column depth है, and small b is column width. So column width and column length, whatever you can say, depth. So and this H is footing depth of foundation. You can assume, let's say it is a 1 meter. And water table, let's say there is no water table, so it is 0. There is no moment, let's say. So 0 moment and 0 horizontal force due to earthquake or wind. Only axial load on the column. Are you getting how to input this?
Yes, sir.
Yes, sir.
See, this is
ये एक्सियल लोड लिए हम लोग एज्यूम करके लिए ना 1500.
हाँ 1500 लिया है zoom करके. See, it is coming from the analysis. Okay, वो analysis से कैसे आता है देखेंगे हम.
Yes, sir.
Okay, so there is no moment and horizontal force in the footing, only axial load. So we will design the footing for axial load only. And the case is dead load plus live load. We are not considering any wind or seismic case. Now go down. Now you will see here. There is a footing weight which he has calculated automatically, this sheet. Okay. So by how to calculate the self weight of footing? Anybody? Volume of the footing into density of concrete, that is 20.
Density of.
So whenever you put any size here, it will calculate the footing weight automatically. In our problem, manual calculation, we have assumed 10% something, isn't it?
Yes, sir.
So see, this
Yes,
assumption is always wrong. Always, if you can calculate accurate weight of the footing, then it is correct method actually. But in manual calculation, we don't know what will be the size of the footings. That's why we are assuming. So it will calculate automatically. So we need not to bother about the weight of the footing. And there is also, apart from that, there is overburden. So there is a weight of the soil here. So see, we have not calculated in manual calculation, but there is a weight also here. ये soil जो है ना ऊपर वाला, there will be weight of footing here, and again there is a weight of soil here. This is a soil weight. Overburden बोलते हैं इसको. So overburden भी है उसमें. Okay. So it has calculated the weight of the soil also here in this case. अभी यहाँ भी बताना बाकी है मेरा. I'll show you. So there is a overburden weight, that is soil weight also, and there is a self weight of footing. So it has already calculated and it has added into 1500 kilonewton, which is coming from the column. So and we get these column loads from the analysis from StatPro or ETAP software. Load on the columns, and it is automatically adding the soil weight and self weight of the footing. So total weight is 1618 and not 1500. Please keep in mind, as there is no moment, so there will not be any moment actually. No pressure, upward pressure will not be due to moment, only axial pressure. And these are the stresses, that is nothing but pressure, bearing pressure on soil. P upon A. P is 1618 divided by A is area provided. Area provided is 3 into 2. So it will calculate automatically this P divided by area of footing provided. So there are 4 corners. It is calculating the stress or bearing pressure at 4 corners. अभी ये क्यों आ रहा है? This is coming due to moment. I will tell you ये कैसे आता है. So कितना आएगा pressure? P upon area provided. So 269. Then now here it is calculating the bending moment at a distance x11, means face of the column as per manual calculation. So this is your face of column. So it will calculate the bending moment here in this x direction, and it will calculate the bending moment in y direction also. So bending moment here it is 360 and here it is 271. Okay. Now it is calculating D required. So we have already used that step. Calculate M R B D square. वो हमने कैसे D निकाला था? This way, this method, D required. M, this is nothing but R B D square. So this is the sheet is calculating automatically. No need to this. Now here you will see this is a red color. When it is a red, that means the depth provided is not sufficient. Okay, and that's why it is showing is 470. Actually required is 471, and you are providing D as a 300.
300.
So कितना डालना पड़ेगा इसमें? कवर ऐड करके कितना आएगा इसका?
521.
So let's say 0.525. Take 525. ये भी नहीं आ रहा क्या?
550.
600. Okay.
Yes, sir. Yes, sir.
Now it is no red color, so it is safe. Now here there is no any red color over here, so it shows safe. Okay.
Okay, sir.
So bending moment depth criteria is satisfied. Then bearing pressure criteria is also satisfied. It is less than SBC. Now we will design the footing steel. I am removing this because I am designing this footing in this line. First, only one footing. So we will provide the steel in one footing only. Now let's assume the cover as 50 mm to the footing. Assume the diameter of the R as 12 in both the direction, along L and along B. Okay, 12 sorry. Diameter is along L 12 mm, along B 12 mm. I am considering. Now here can you see the red color less than 2628. So here you are putting 12 number of bars, which is nothing but 12 at 175 spacing. This is not sufficient. Increase the number of bars. Let's say 13. Is it okay? No. Let's make it 14. Is it okay? No. Make it 15. No. 16. 17.
20.
18. नहीं आ रहा क्या? Along B, it is taking as 20 लिया तो पास हो रहा है यहाँ, 18 लिया तो not pass, 19 अभी let's see क्या हो रहा है देखेंगे अभी. That means this is 23 में आ रहा है क्या? 24. Now
Yes, sir,
24
24.
number of bars are passed, but the spacing कितना आ रहा है इसका?
85.
85. Okay, that means we generally provide 100 and more than 100 spacing. So what can we do then? क्या कर सकते हैं?
बार डायमीटर इंक्रीज कर सकते हो.
Increase the bar diameter, let's say 16. Now again go here. Let's make it 20.
Yes.
18 करो पहले. 18,
18 बना ली.
15, 14, 12, 13. That means 16 at 160 चाहिए spacing. So you can consider as a 16 at 150 here. Here how much you want? 12 at 155. Now you got this procedure.
Yes, sir.
Now
अभी भी रेड है
yes.
सर.
रेड कहाँ है? यहाँ.
नहीं वो 13 का में जहाँ.
कहाँ तो आ रहा है क्या रेड? हाँ रेड है क्या?
हाँ 14 आएगा सर.
14 आएगा.
150 spacing.
Okay. So here there is no reinforcement not required. मतलब top reinforcement is not required. The only bottom reinforcement is we require. Now here see. Now this is a shear XX. Okay, so steel satisfied but shear is not satisfied. Shear XX. Tau C is 0.228. That is at a distance D from column face. Means what? One way shear. Yes or no?
Yes sir.
ये one way shear है. And this is 0.5 D from column face. It is a two way shear. So it is not satisfied. Now what to do?
D increase करना पड़ेगा.
D increase करेंगे. Let's say 0.65. नहीं हो रहा है.
9.0. 0.9.
75 करेंगे पहले. Don't increase more. से अभी तो वो कर रहा है ना automatically. 0.75 हो रहा है क्या satisfy?
Yes, sir.
थोड़ा reduce करेंगे. See, as it is a spreadsheet automatically doing the things for us. To the trials. 1 सेकंड में हो रहा है ना काम. 0.7 को हो रहा है क्या? नहीं हो रहा है. मतलब 0.75 ही चाहिए. Okay. Now it is satisfied. So one way, two way shear is also satisfied. Right? And if you go down, okay, अभी ये कभी-कभी ये दिखाता है, but ये थोड़ा length की वजह से हो रहा है, but it is okay. There is no red. So this is the procedure. Now one point I have missed actually here, which is nothing but the SBC. Whenever you write over here, it should be gross SBC. So generally we get the SBC from geotechnical report, which is net SBC, net soil bearing capacity. Let's say it is net SBC we got as 300 kilonewton per square meter. Now gross SBC is
weight of footing भी plus हो जाए.
हाँ, तो
soil
footing
भी
में
plus.
या सो उसमें gamma DF बोलते हैं. soil gamma soil into depth of foundation वो भी ऐड करना पड़ेगा SBC में.
Yes, sir.
So gamma कितना है soil का? 18. And depth of foundation कितना लिया है हमने ये वाला H?
1 meter लिया था sir.
1 था क्या? तो 1 meter.
Yes, sir.
प्लस ये हमारा 300 है, तो कितना आएगा?
319
318 न्यूटन, किलो न्यूटन,
into yes sir
318 ना?
yes sir
तो यहाँ 318 डालना है आपको, 318। ओके,
okay sir
अगर ये 2 मीटर रहता फुटिंग का हमारा ये डेप्थ, तो 2 इंटू गैमा डीएफ मतलब 36 ऐड हुआ होता, तो 3।
okay sir
नाउ दिस विल बी 1.25, मतलब 25% इंक्रीज करना है मुझे इनटू दिस, ये वाला 398 आएगा। दिस इज फर्स्ट पॉइंट। नाउ लेट मी आस्क यू क्वेश्चंस। अभी एक काम करेंगे, चलो ये 2.5 बाय 1.5 करता हूँ, एजम्पशन है मेरा। आई स्टार्टेड फ्रॉम दिस, कैन यू सी दिस रेड कलर ओवर हियर?
yes sir
बेयरिंग प्रेशर इज 423।
Yes.
तो बताओ क्या करेंगे चेंज सो दैट द प्रेशर इज लेस? सो वेयर टू चेंज? शैल आई इंक्रीज द डेप्थ ऑफ फाउंडेशन? शैल आई इंक्रीज द थिकनेस ऑफ फुटिंग? क्या चेंज करने के बाद बेयरिंग प्रेशर कम होगा?
area.
Area of footing. So you should increase the area of footing. All of you know that if you increase the area of footing, the pressure will be less. So you can, let's say 2.75. पहले ये बढ़ाता हूं मैं. Is it okay? It's still red. So let's make it 1.6. देखो, still red. 1.8. Still red. थोड़ा यहाँ भी बढ़ाएंगे, अभी 3 करेंगे. 1.8 अभी हो रहा है प्लस 300. ओके,
yes sir
इफ यू वांट टू ऑप्टिमाइज, यहाँ ऐसे भी कर सकते हैं 2.9. ओके, स्टिल ओके, स्टिल रिड्यूस लिटिल बिट 1.7 है क्या? नहीं,
1.8
1.80. okay, see we are doing trials, that's why we can optimize the sections, huh? So whenever we design, if you use the Excel sheets or softwares, then you can optimize. If you do it manually, then you cannot optimize, because to optimize you need to do the design 4 times, 5 times, then and then you can optimize. Otherwise it is really difficult to do the manually, and that's why the spreadsheets are important in our case. Now you have understood that if the design is failed by bearing pressure, then you need to increase the size of the footing first. Okay, now I will tell you, ask you, if this small d required is showing the red color, that means d is not sufficient. So what you need to increase?
thickness
Thickness, t.
yes
So
sir
you need to increase this. Let's say 0.55. Is it okay? Okay, 0.55 is okay. 550 mm thickness. Now go down, so all is okay. Now you put the steel here. You can assume this as any diameter. अभी ये करो. So as we have already discussed that if the spacing is less than 100, try to increase the diameter.
yes sir
Okay, so increase the diameter and then again reduce the steel. Start with some number. 15 is okay, 12 is not okay, 13 is not okay, 14. So
14
you just do the trials from minimum to maximum till it gets satisfied. So don't increase, don't put directly 20 or something. It will be over design, right?
okay sir
Yes, sir.
So this is the procedure. So you can put the steel. Now you see here, if there is no reinforcement required, that is top is not required. Now here it is a red, that means one way shear is not satisfied. Now what to change? क्या क्या change कर सकते हैं हम? If the shear stress is
Depth of footing.
yes, so
Depth.
there are two choices. Either you can increase the depth. So increasing the depth is always good choice. Or there is one possibility, you can increase the steel also. Okay. तो यहाँ मैं दिखा था स्टील करने के बाद भी हो सकता है वो. Let's say this is 20. For
So based on
Stress-
the depth,
Yeah, so yes, so always shear stress के लिए best option is
depth
depth ही है, क्योंकि steel बढ़ाने के बाद the footing will be very heavy, right? So but yes, it
cost will
changes
increase.
because all of you know that once you change, I'm just telling you what it is depending on PT also, isn't it?
Yes, sir.
So if you increase the PT, see this, as you increase the PT, the permissible shear stress is also increasing. अभी ये 0.25 को 0.36 है and 0.75 को 0.56 है. That means your capacity gets increased, shear capacity, by increasing steel also. But a good choice is increasing the depth so that you can optimize the section. So you should know the dependency of each parameter. So ये करो 0.6. फिर भी नहीं हो रहा है क्या? अरे हाँ, वो तो 0.75 था previously, तो 0.75 करेंगे. These are the steps of design of footing, and you know the every, see this tau c, you know tau c we are getting from the code. This tau v is actual shear force stress, right?
Yes, sir.
Here you are getting the PT value 100 AST upon BD. So everything we are getting, and this is a two-way shear force. This hatch area into upward pressure. Then this is your actual shear stress. This is permeable stress. वो जो KS वगैरह formula था ना, वो है, that is the formula, and it is
Yes, sir.
checking. Okay, so these are the steps, and shear in Y direction, shear in X direction, because we are having a two-way bending. Okay,
Yes, sir.
and we are also having shear steel also along L and along B, because we are having two-way bending, MX and MY.
Yes, sir.
And the bending moments in X direction are here, and a bending moment in Y direction are here. So these are the steps, and you know the now terms. So you can understand the Excel sheet very effectively. Now let's go a little higher to understand. So whenever there is any bending moment on the column, so all of you know that how we get that bending moment? Biaxial bending. So there is all
Biaxial, yes.
biaxial भी रहेगा ना column में. All of you know that we get the moments in the column. So let's say we have a column, or we have a column here. So this is our column, which we are resting at the footing. यहाँ footing रहेगा समझो. So we have a axial load here on the column PU, and let me assume this as x-axis, xx, and this as y. Okay. So all of you know that there is a moment like this. So there is maybe mx, and there is a my. About x, about y. Do you know this? So this is a nothing but biaxial moment. We have,
Yes, sir.
in 3D model, you might have seen. So this is your bending moment due on the beam due to this. ये bending moment है हमारा समझो mx, and if this is a 3D building, then we get biaxial moment. तो ये ऐसे भी moment आएंगे, and there will be moment in other direction अभी ये ऐसे कुछ तो mx and my, you know it. So these are the bending moments, so not bending moments in the column mx, my, and axial load on the column. Okay.
Okay, sir.
So now we get, let's go into the results actually. Now, have you understood how to see the results of support reactions in the ETAP? बताए क्या सर?
Yes, sir.
So you can see here X, Y, and Z coordinates. So in ETAP actually we have this axis. ये vertical है. Yeah. So if you look at this, again I'll show you this image. So this X, this Y, and this Z. So I will 3D global axis I am saying X, Y, Z.
Z vertical axis and XY plane.
X, Y, and this is Z. Okay. So these are the axes and we are having a building here. Correct. Now, whenever we get any forces on the supports, see here, let's say I'm designing this column, for example. So I will get the support reaction over here, fixed support. Whenever there is a fixed support, we get axial force, we get moment in X direction, moment in Y direction. That means two biaxial moments we get. But in ETAP, actually, we don't get X and Y, but we get this. So when I click on this support, right click on this support, you will get these forces. Now the force 1, 2, 3 and moment 1, 2, 3. Now 3. Now in ETAPs, this X corresponds to number 1, Y corresponds to number 2, and Z corresponds to number 3. So whenever I say 1, this direction is Fx. So force is Fx. And if you see this moment, then this moment is Mx. Okay. Then the force here in this direction, I'm saying. In this direction, the force is Fy. And if I say the moment is My here, like this, about X, about Y. And here also the force is Fz. And the moment is Mz. समझ में आ रहा है? Are you getting all of you?
Yes, sir.
But as we are saying X is a 1, so Mx is nothing but M1. Okay. Fx is nothing but F1. Fz is nothing but F3. Mz is nothing but M3. M3 or M33. M11. And here also Fy is nothing but F1. And My is nothing but M22. Sorry, not 1, here 2. F2 and M22. Getting this? Now if you see the results of the ETAPs, you will see here 1, 2, 3. Force 1. This is nothing but F1. Force 2, F2. Force 3, F3. Okay. And
Yes,
moment is M1, M2, M3. So here you can see this value is more 3. That is F3. So F3 is more. That is, all of you know that this is the column direction. Yes, yes or no? And that's why now here this axis मेरा कौन सा है फिर? This axis is nothing but ये axis है ना मेरा? This is Z axis मतलब 3, right? That's why this load is nothing but ये मेरा ये रहेगा. कितना लोड रहेगा? 1154. So this is my 1154. Then Mx is nothing but M1. 1 is nothing but, बताओ क्या क्या है? M11 1.06. अभी ये x भी रहेगा ना, fx. ये डायरेक्शन में fx भी है ना. Fx is nothing but F1 is nothing but F1 कितना है बताओ? Force 1 1.52. 1.52. और क्या बाकी? Fy ये है. Fy is nothing but F2. Nothing but F2 7.1. अभी मैं साइन कन्वेंशन अभी जानबूझ के नहीं ले रहा. राइट. एंड देन अगेन क्या है? My है, बाकी है ना. My मतलब M22 मतलब मोमेंट 2, ये वाला 0.57. Are you getting?
Yes, sir.
Okay.
Yes, sir.
And generally there is no torsion in column, so forget about that M33. फिर भी यहाँ दिया रहेगा थोड़ा सा.
सर स्टीफनेस मॉडिफायर क्या होता
0
है?
है. कहाँ है वो?
सर वो ई टैग के अंदर था.
नहीं, we will discuss that separately, बताएंगे. अभी तो नहीं है कंसर्न वो सब्जेक्ट का. ओके. Now you got how to see get the results from the 8 tabs. So you got all the results fy, fx, then m11, m22 and ये f3 मतलब fz है ना ये मेरा pu रहेगा fz. Okay. Now see what is happening here in Excel sheet. We need to put the results in terms of mx, my, and we are getting the results from a tab in terms of m11, m22. So don't worry, you can write like this and then it will be easy for you. या ऐसे लिखो 111 भी लिखना है और mx भी लिखना है. That means our case mx कितना है 1.06, pu कितना है 1154, which is nothing but f3. So 1154. Let's put these numbers here. pu is 1154. mx यहाँ नहीं, यहाँ देखा mx कितना है 1.06. mx 1.06. my 0.57. hx. Now here it is hx. That is fx. Okay. Here you can see this hx. In x along, this is the x. So this is hx and this is hy. कितना था वो 1.52 and this is 7.1. Getting this? How to put these values? We get it from the ETAP modeling, 3D results, biaxial moment and horizontal force also. Horizontal force means we get it due to earthquake and wind loads. Here, this is hx and this is your hy. Corresponding to y, along y-axis hy, along x-axis hx. This is hx and this is hy. Okay. Now what will happen due to the moment actually? Tell me. क्या होगा? Now as we are only considering gravity load, these moments are coming less. For the time being, what I'm doing, let's say mx is 10, my is let's say 5. Okay. I'm just increasing the moments. थोड़ा ज़्यादा ही लेता हूँ. Let's ignore this. So these are your inputs. Now we want to design the footing. बताओ कैसे करना है अभी? Or okay, before that, let me ask you, what will happen due to the moment x and y?
So
Footing में क्या होगा?
non-linear distribution होगा सर load का.
Yes. So there will be additional stresses in the footing. Let's say this is your column, and let's say this is your footing. Okay. So let's say this is your axial load P, and there is a moment here in this direction as mx. Okay. So what will happen in this case? So all of you know that in any footing, the column is resting on that, and due to that there is a biaxial moment on the column, on the footing rather. Let's say this is the case, and we are having this axis x, y, y. Oh, I'm considering this as x. So this will not be mx, it will be my. So ये मेरा my है, समझो my, and this is my mx. So the better way to show it on column यहाँ रहेगा मेरा my, and this will be, and there is axial load here on this. So tell me what will happen due to this my. For understanding, I'm just showing this my here, my and m. For understanding, just actually it is coming on the column and then it will transfer on the footing. So what will happen to this moment? So as I shown you this my. So what will happen due to the axial load? Tell me. Due to the axial load,
Uniform distribution of load.
so all of you know that due to this axial load, there will be pressure, upward pressure, that is P by A. Yes, which is uniform. This value is nothing but P upon area of footing, which is a uniform pressure, upward pressure. What will happen due to this bending moment? Plus there will be additional pressure or additional stress. So this is your axial stress, we can say axial stress or pressure, whatever you want, and there will be bending stress also. So ये क्या है, कैसे रहेगा bending? As this is a direction of moment, so there will be compression in this direction and there will be tension in this. Okay, so कैसे रहेगा ये? So let's say if you assume the direction, no, compression ऐसे निकला है ना मैंने. So this will be your compression, let's say, correct, and then there will be tension. So here it is a tension, here it is a compression, and what is the pressure? Pressure will be m upon my upon z, correct? Zy you can say. This is also pressure my upon z, right? So there will be axial stress or pressure due to axial force, and there is a pressure due to bending moment, that is bending stress. Okay, so this is the bending stress developed due to the moment y. Now will there be any bending moment, any pressure? So this is the first part, and all of you know that there is mx also. So in this direction also there will be pressure. So the pressure will be due to this moment mx, and this pressure is nothing but mx divided by zxx. Now I am asking you one question. Let's assume this. यहाँ क्या लिया है हमने? x y से, ये क्या यहाँ उल्टा है क्या? Y horizontal, x vertical. Okay, we will काम करेंगे. Let's follow as per the Excel sheet only, so that there will not be any confusion. So our horizontal axis in Excel is Y and vertical is X. Okay, so this is my Y. This is my X. Now this will be my MX. This will be my MY. Yeah, MY, MX. So the pressure, this pressure, this will be MI, MX, na? So this will be MX upon ZX. MX upon ZX. Are you getting this? क्या चल रहा है यहाँ? This is my MY, so it will be
Yes.
MY upon ZYY and MY upon ZYY. Now here you can see here, there are 4 points, 1, 2, 3 and 4. Okay, so 1, 2, 3, 4. One, 2, 3, 4. Now you can understand, due to the axial load, the pressure is uniform. So the pressure at all points 1, 2, 3, 4, it will be same due to axial load. But due to bending moment, it will be different. So what is happening here? Due to this bending moment, Mx, what is happening? This is going in compression. Yes or no? This zone. And this zone is going in tension.
Tension.
Correct?
Yes,
So
sir.
as this is going in compression, that means this point number 2 and 4 both will go on compression में जाएगा नहीं?
Yes, sir.
So if I ask you to calculate the pressure at point 2, P2 बोलता हूँ मैं इसको. So कितना आएगा pressure मेरा? First will be P upon A due to the axial load, and this is the compression here. So M upon Z, Mx upon Zx, right?
Yes, sir.
तो ये प्लस होगा ना, क्योंकि कॉम्प्रेसिव है वो. So प्लस Mx upon Zx.
ZX.
अभी ये हुआ, दिस इज ड्यू टू एक्सियल मोमेंट x. अभी मोमेंट y से क्या होगा पॉइंट 2 को बताओ? ये 2 and 1 कॉम्प्रेशन में जाएगा ना, क्योंकि ये ऐसे है ना मेरा.
कंप्रेशन में हो जाएगा सर.
ये भी
Yes,
कॉम्प्रेशन में आएगा. My upon Zy, My upon Zyy. So this is my pressure at point 2. Now if I ask you pressure at point 1, so P by A तो सेम ही है कॉम्प्रेसिव. नहीं प्लस है कि नहीं देखेंगे, पता नहीं. अभी Mx, x की वजह से 1 का क्या होने वाला है बताओ? This is my x. So it is going in tension. Yes or no?
Tension
टेंशन
negative.
में जा रहा है, मतलब माइनस mx divided by zxx. अब ये माइनस में क्या है? Now what will happen due to my? So this is your my
Compression.
ये
Operation.
compression, तो
Compression.
प्लस रहेगा वो my upon z. Now P3 कितना रहेगा? P by A. अभी देखना पड़ेगा. mx का क्या होगा? mx due to mx it is P3 ना. So this is your mx. So see, if it is a tail, then tail will go in
Tension.
tension and this arrow will go in compression. So tail is here at 3 point. So minus correct है ना?
Yes, sir.
And here my will be
Minus.
minus m3 का है ना? And P4 P by A. P4 due to x it will be in compression.
Yes, sir.
And my की वजह से 4 को क्या होगा?
Tension.
Tension minus. That means you can see here there is a possibility of tension and more pressure also. So as this P2 case will have more compression, right? So whatever pressure you are getting pressure due to axial load plus pressure due to moment x plus pressure due to my. That means in this case the axial pressure or bearing pressure will be more, right?
Yes, sir.
So that means there is a possibility that it will increase, it will be more than SBC. Now here there is a minus mx, that means whatever total pressure is there, it will reduce. इस समझो ये वैल्यू मेरा p by a का वैल्यू समझो 100 है, समझो mx upon mz का वैल्यू समझो 50 है, and my upon zy का वैल्यू 25 है. So what will be the total pressure? 100 plus 50 plus ये 1 का प्रेशर, p2 का प्रेशर, it will be 175. Yes, correct.
Yes, sir.
इसमें कितना आएगा? 100 minus 50 मतलब 50 plus 25, it will be 75. ये इन किलो न्यूटन पर मीटर स्क्वायर प्रेशर निकल रहे हैं. इन दिस केस कितना आएगा? 100 minus 50 minus 25 मतलब 25 आएगा. एंड इन दिस केस 100 plus 50 minus 25 कितना आएगा? Getting? So this pressure is more and it should be less than SBC. अभी ये तो already less है, तो there is no need to compare. That means point number 2 may be having more pressure. So that's why what we are doing in this Excel sheet, actually, we are calculating the pressure at every point and you get over here, right? So let's design this footing now. Let's say L, अभी L कितना लेना है हमें? Approximately, let's start somewhere अभी. कर सकते हैं approximations, but ठीक है. Thickness of footing, assume let's say 0.5. Column size is 0.6 by 0.3. Depth of foundation, in this case let's check 2. Water table 0 है समझो. And actual loads we have already put. Now go over here. You satisfy हुआ क्या? Say I don't want to satisfy. देखो. I'm assuming 2 meter by 1 meter size of the footing in the beginning, as assuming this. Now once I go over here, you can see here the point number 2 is having more pressure. कितना आ रही है? 696. Correct?
Yes, sir.
So definitely यही ज्यादा आएगा ना. We have already seen कि कैसे आ रहा है वो. And कौन सा कम आ रहा था हमारे केस में? P3.
P3 is 25.
यहाँ P3 कम है ना, सबसे कम P3 है ना.
Yes, sir.
So see, that is the philosophy. And how these numbers we are getting? So whatever these calculations are there here, there are calculation behind. This is a P by A plus M by Z minus M by Z, मतलब MX, MY, वो जो है ना calculation, they are done here behind in the program rather. So as that means our pressure is not satisfied. So what to do? Increase the size of footing. Go ahead. Still it is not satisfied. Again go increase little. समझो 1.8 करेंगे. Okay, yes. Now it is okay. SBC is satisfied. First case, we are getting moment. Go ahead. Let's assume diameter as a 12 mm. Okay. Now these 15 bars are not satisfied. So what to do? Increase. 18, not okay. 19, not okay.
So it is 18. स्पेसिंग कम हो गया इसमें. 19
स्पेसिंग कम हुआ ना तो 16 करेंगे. अभी ये 18 में भी
18 हो
15
जाएगा.
में
Yes, sir.
15, 12, 10, 12. यहाँ 15, no 16.
Yes.
12 mm का 180 spacing, 16 का 155 spacing. Go down. Top not required. Shear stress not as satisfied. What to do?
Depth of required increase.
Yes. So depth कितना था हमारा? 0.5 का करेंगे 0.75 से. Is it okay? Okay.
Okay, sir.
Still try it 0.7 को हो रहा है क्योंकि ऑप्टिमाइज भी करना चाहिए ना. पास होने के बाद डोंट स्टॉप, ट्राई टू ऑप्टिमाइज. 0.7 किया तो हो रहा है 0.7. यस.
Yes, sir.
Even you can try 0.65, and that is up to you. You can try many times. Now what, anything need to change? Is it okay? आपको क्या लग रहा है? So is it okay in all respect?
सर लेंथ थोड़ा कम करके देख सकते हैं.
हाँ, वो तो ऑप्टिमाइज यहाँ करेंगे. हाँ, लग रहा है क्या आपको? 2.7 by 1.7 हो रहा है. Now, okay, let me keep that as it is for the time being. Abhi, whenever you change the depth, see what you are doing, it was red here somewhere, and that's why you changed your depth, correct?
Yes, sir.
Once you change your depth, change the steel again, because now steel is more. When you change the depth, the minimum AST criteria may not be satisfied. See here. So you need to, whenever you change anything, again go to the other parameters and check it. Don't
Okay.
keep it as it. Steel bhi change karna hai. Once you change the depth, you need to change the steel again. So here it was saying wrong design, because minimum AST is not satisfied because depth is more. Correct? Again go over here. Can you reduce the steel? Yes, you can reduce here. Can you do it 9? Yes, 8. That means there is a possibility that I can reduce the diameter. So go 12. Now increase the steel. 12, 15. Yes. Getting this? क्या किया मैंने?
Yes, sir.
So as iterations are done, but do the iteration correct, so that each and every parameter is satisfied with the optimum design. Okay. It may happen in this sheet that you will make it safe, but it will not be optimum. So you need to try at every level again and again. So if you change the depth, change the steel, again check whether you can optimize, again go here somewhere, again change here. Can you change the size of the footing? Can you again change the depth of footing? So do the iterations. And finally, optimum design should be there. So I hope all of you got this. समझ में आया सभी को? Design of
Yes,
footing.
sir.
Yes, sir.
Yes, sir.
Yeah, so we will share you.
Sir, that thickness we have taken,
Uh-huh.
if we use step footing, then what to do?
See, step footing, it is not for step footing, it is for pad footing. And I generally don't recommend step footing.
Okay, sir.
Do pad footing always, whatever may be the thickness. So there are consequences regarding the design and construction also. So we generally don't recommend step footing or slope footing. Okay.
Okay, sir.
So there is a reason for complexity of design, then constructional practice. So it is always to provide pad footing. Generally nowadays, everybody is using pad footing only. Yes, bolo.
सर आपने फाइल तो शेयर कर रखी है, उसमें सर पासवर्ड आ रहा था एक्सेल शीट वाले.
Password? नहीं.
Yes, sir.
I will check.
सर
मतलब it is not opening. ऐसे open ही नहीं हो रहा है क्लिक करने के बाद.
सर वो आपने
पासवर्ड
जब
पूछ रहा
एक साथ वो फाइल्स डाली थी ना, तब सर ओपन नहीं हो रहा था. मतलब ओपन तो हो रहा था, उसमें पासवर्ड मांग रहा था किसी तरह का.
Just a moment. अभी ये मेरे पास है. अभी मैं बताता हूँ. आपने डाउनलोड तो किया है ना? You have downloaded the files and you are getting like this. So let's say if I click on the here and I'm clicking on the footing, let's say. Do you have these sheets like this?
नो सर, वो वहां से डाउनलोडिंग के टाइम पे ही पासवर्ड मांग रहा था सर.
Download के टाइम मांग रहा है क्या?
बाकी किसी के आ रहा है क्या इस टाइप से? किसी ने
आया नहीं था कभी. I'll check it out tomorrow. Okay.
एक बार सर
पहले नहीं हुआ कभी
ने
किसी को?
चेक किया होगा तो वो भी बता सकते हैं उनके कैसे.
Anybody from you? Everybody is getting the same problem. Hello. Are you getting the same problem, all of you?
सर मैंने भी एक ही बार ट्राई किया था, तब उसने पासवर्ड पूछा था.
पूछा था क्या? Then I will check it again. I'll upload it again then.
यस सर,
ओके
थैंक यू
सर.
सर.
Okay.
सर ये
हाँ बोलो.
सर ये ई टाइप में बार बार प्रॉब्लम हो जाती है सर, वो चलते चलते बंद हो जाती है, और फिर आरसीडी से का फाइल ट्रांसफर होता है उसमें भी दिक्कत होता है।
हाँ ठीक है ना, यू कनेक्ट, कैन यू कनेक्ट इन बिटवीन इन द ऑफिस आवर्स आल्सो? कुछ प्रॉब्लम रहेगी? सी इफ यू ऑल ऑफ यू आर हैविंग एनी पर्सनल इश्यूज।
कनेक्ट सर से करते हो तो अभी वो 10 बजे टाइम देते हैं सर, तो 10
नहीं
बजे
नहीं, आर यू गेटिंग सॉफ्टवेयर इंस्टॉलेशन रिलेटेड इशू और टेक्निकल इशू?
सर इंस्टॉलेशन तो मेरा टेक्निकल इशू हो रही है उसमें, कुछ
क्या हो रहा है मतलब स्पेसिफिक क्या पॉइंट?
फाइल ट्रांसफर नहीं हो पा रही है सर। फिर
एमडीबी नहीं हो रहा क्या? एमडीबी
नहीं सर, वो नहीं हो रहा था। फिर मैंने ये 16 को अनइंस्टॉल किया और 19 को मैंने अभी डाउनलोड किया, अभी इंस्टॉल करके उसको देखता हूँ।
नहीं नहीं, सी was it a problem of ETAB or was it a problem of converting it into MDB file RCDC में?
सर ई टैब में तो ये हो रहा था कि फाइल मैंने सेव करके रख रहा था, वो फिर क्या बोलते हैं, फिर वो सेव ही नहीं हो रहा पा रहा था, पता नहीं क्या इशू हो रहा था उसमें। और इसमें आरसीडी फाइल जा ही नहीं रहा था। फिर
नहीं, अभी 16 में अनइंस्टॉल कर दिया क्या?
हाँ मैंने अनइंस्टॉल किया, अभी 19 मैंने मांगा है सर, डाउनलोड किया सॉरी।
19 ठीक है, आई एम नॉट श्योर 19 से आरसीडीसी में ट्रांसफर होगा क्या नहीं, क्योंकि सी ये सॉफ्टवेयर का प्रॉब्लम क्या है, वर्जन से ना रिलेवेंट यूज करना पड़ेगा। 19 से आरसीडीसी में एमडीबी फाइल होगा कि नहीं मुझे पता नहीं, आई नीड टू चेक इट आउट। ओके
सर कौन सा वर्जन, एक बेस वर्जन आप बता दें तो उसमें
एक्चुअली 16 इज एवरीबॉडी इज यूजिंग 16, सो व्हाटएवर इंस्टॉलेशन प्रोसीजर वी आर गिविंग, उनको कभी दिक्कत आया नहीं था पहले, फिर भी देखना पड़ेगा।
हर सिस्टम का अलग अलग रिक्वायरमेंट होता है सर।
नहीं, इफ द वर्जन इज डिफरेंट देन इट इज डिफरेंट रिक्वायरमेंट।
नहीं आपने जो भेजा था 16 का वो उसी पर मैंने इंस्टॉल किया था।
ठीक है,
उसमें एक बार फिर मैंने इंस्टॉल किया 16 को, तो रन एज डेटेड वो रन नहीं कर रहा था।
नहीं नहीं, वो फिर से अभी यू नीड टू कांटेक्ट अजय। बाय द टाइम 19 हुआ है क्या इंस्टॉल?
नहीं सर अभी मैं करके देखूंगा, लेकिन और लोग का हुआ इंस्टॉल 19, वर्क कर रहा है वो।
कर रहा है क्या? फिर ठीक है, वर्क कर रहा होगा तो कुछ प्रॉब्लम नहीं, डू इट फर्स्ट एंड वी विल चेक इट आउट।
लेकिन सर वो ग्रुप में हम लोग मैसेज, वो फाइल ट्रांसफर होने में थोड़ा प्रॉब्लम हो रही है। हाँ
ठीक है, वो ऑफिस आवर्स में लेट्स वी विल सी क्या क्या हो रहा है। ओके
सर ऑफिस आवर में तो वो सर रात में 10 बजे टाइम देते हैं हम लोग, मेरा इसके बाद एक कार क्लास है सर, तो इसीलिए मैं नहीं ले पाता उनका।
नहीं नहीं नहीं, मुझे है ना नहीं, सॉफ्टवेयर इंस्टॉलेशन का प्रॉब्लम रहेगा तो उनको ही पूछना पड़ेगा। अगर एमडीबी है वो कुछ है तो देखेंगे। सो फर्स्ट ऑफ ऑल इंस्टॉल फ्रॉम योर साइड।
ओके सर। और
काम टाइम निकालना पड़ेगा, रात को तो रात को एक बार ही करना है ना।
सर एक चीज और, ये प्रैक्टिस के लिए कुछ फाइल चाहिए ऑटो गाइड का सर, क्योंकि वो दिक्कत हो रही है, प्रैक्टिस भी ढंग से नहीं हो पा रही है।
अभी जितना सीखा है उतना तो किया है क्या?
सर उतना मैंने कर रखा है, लेकिन
आपको प्रैक्टिकल प्रॉब्लम चाहिए क्या?
हाँ प्रैक्टिकल प्रॉब्लम चाहिए सर।
वो G+5 किया क्या पहले?
मैंने
जो ट्रेनिंग में था वो?
हाँ उसमें कुछ एरर आ रहा था, तो मैंने सर से पूछा था, वो बताया, तो फिर मैंने उनको फाइल बोले थे कि मैं भेज दूंगा, तो तब बोले भूल गया हूँ इसलिए नहीं भेज पाया।
ठीक है, मैं भेजता हूँ।
ओके सर।
ओके okay, any other questions?
Sir, when you take these reactions from this ETAB now to input in Excel sheets, then we don't need to consider the signs, this minus and all, this minus.
Yeah, you can consider, yes, you can consider that will have a problem. Yeah, you need to consider, you know how the signs are there.
Actually, I am not sure, sir, about this.
Yes. It was positive sign, I think. This one. Right hand thumb rule. All of you know this. Okay. So this MX, this is a right. If you do use the right hand rule, then this is the direction of thumb and this is the curly fingers. Okay. So this is your positive value. If this value is negative in ETABS, so whatever we have seen, there are some negative values also. Okay. So when it is a negative, then put the negative values. So I would suggest in Excel program, Do it. क्या हो रहा है? हाँ. So in Excel program, you can use the sign conventions accordingly. This is plus. If it is minus, then put here minus value. So I would suggest put the values as it is, minus, plus, whatever. Okay. Getting?
That means it will change where the pressure is more, like
Correct.
that?
Yes. Minus that
Okay.
will value change. It will reduce actually. If
Okay.
all the values are positive, then whatever I told you
Two
will be
will
valid.
be maximum. The 2
Yeah. Otherwise, the things will be different. If all the values are positive, then 2 will be maximum.
Yeah.
And yeah, if this my is, let's say, like this, which is negative, then definitely this will change. This plus minus values will change.
That means if we get the moment value positive, then it will be clockwise in foundation. I mean, in the column here.
As per the right hand rule, we can say.
Okay.
And I know that whenever all of you will start doing on this, you are going to get doubts actually. मुझे पता है, but you ask at that time only once you start that. I know there are a lot of other things inside there, but start working on that first. Okay.
Okay. Sir.
But create questions. Create questions. Okay. So start practicing whatever ETAP models you have prepared. Please design 2-3 columns. I insist all of you, at least you design the footing 1 or 2 by manual calculations as per this procedure, whatever I discussed.
Yes.
And then design 4-5 columns using Excel programs. Columns, not footings, I'm saying. So that you will have a practice.
Okay, sir.
And RCDC, I know that it is giving directly the design. So that is the final phase, we can say. Once you understand everything, then you can use that RCDC. It will quickly give all the column design, footing design within few minutes. But I insist all of you, please use Excel and manual calculations first.
Yes, sir.
Then use, for the time being, you understand the RCDC software, how to use prepare the MDB, then how to put the inputs and everything. Well, that is a final, we can say, our aim. But the concepts will be clear only by this method, manual and Excel. Okay.
Okay, sir.
So next time we will design the columns using Excel programs.
Okay, sir.
Okay. So thank you all.
सर मैंने एक्सेल खोला उसमें पासवर्ड नहीं मांग रहा है.
नहीं मांग रहे कि हाँ वही तो I don't know किसको. See if you are having any doubts.
अब शायद सर हटा दिया होगा, पहले स्टार्टिंग में आ रहा था सर.
Okay, नहीं तो ऐसे can you do one thing, Avinash? You download that Excel and share on the WhatsApp group.
Okay, sir.
सभी को मिल जाएगा. And I will also do it.
कर लेंगे सर, आज चेक कर लेंगे सर. हमने पहले चेक किया था जब सब आपने एक साथ अपलोड किया था ना, उस टाइम पे चेक किया था उस टाइम. अब हो सकता है सर शायद हटा दिया होगा उन्होंने, वो चेक करना पड़ेगा सर.
हाँ ठीक है. नहीं तो I'll do one thing. अभी मेरे पास जो है ना, I'll share it on this WhatsApp पे भेजता हूँ मैं. आप कीजिए डाउनलोड आपके मशीन पे. Okay.
Okay.
Yes, sir.
Okay. So thank you all.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Good night all.
Good night, sir.
Good night, sir.